Well, this is a big day, guys. We are on our last type of factoring, and this too, like grouping, is going to be totally new to you. This is called factoring the sum and difference of perfect cubes. Okay, so obviously, I know you know sum means an addition sign, difference means a subtraction sign, and perfect cubes mean like they're what they sound, they're perfect cubes. So let's go over the factoring we've done. We've tackled GCFs, greatest common factors. Then we did the difference of perfect squares. Okay, then we did trinomials when A equals 1. We said multiply, add, multiply. We did trinomials when A was greater than 1. That was guess and check. And then we had our grouping, which is when we had 4 terms. All right, and today we are on our last one, the sum and difference of perfect cubes. So let me go back to what we knew a perfect square was. We said we had to recognize our perfect squares, our 1, our 4, our 9, our 16, etc. A number times itself. So a perfect cube is just like it sounds. It is a number multiplied by itself 3 times. So 1 is a perfect cube because 1 times 1 times 1 is 1. 8 is the next perfect cube because that is 2 times 2 times 2. All right, let's think it out. 3 times 3 is 9, times 3 is 27. 27 is the next perfect cube you need to know. 4 times 4 is 16, times 4 is 64. The next perfect cube you need to know. 5 times 5 times 5 is 125. 6 times 6 times 6, 6 times 6 is 36, times 6 is 216. And 7 times 7 is 49, times 7 is going to get me a 343. Now, your perfect cubes are probably not as familiar as your perfect squares. So let me remind you, you can test to see if something is a perfect cube if you go to the math feature and you take the cubed root of it. For example, if I take the cube, whoops, that's not what I meant to hit. If I take the cubed root of 64, it will tell me it's 4. If I take the cubed root of 60, it's not a nice number, so it's not a perfect cube. Okay, if I take the cubed root of 125, I should get 5. So 125 is a perfect cube. So I can test to see if I have a perfect cube using that cubed root button. Okay, now variables. So x times x is x cubed, so x cubed is a perfect cube. X squared times x squared times x squared, remember that you add the exponents when you multiply, so x to the 6th. So if I had x cubed times x cubed times x cubed, 3, 6, 9, x to the 9th. X to the 4th times x to the 4th times x to the 4th. Again, I'm adding the exponents, so that's x to the 12th. X to the 5th times x to the 5th times x to the 5th. 5, 10, 15. I get x to the 15th. And obviously this pattern continues. Okay, so we do want to recognize our perfect cubes. We want to recognize how we can test a perfect cube by taking its cubed root on the calculator if we need to check for ourselves. Now there is some good news in all this perfect cubes. Okay, and here's the good news. There's 2 formulas that you have to know. There's a formula for the difference of perfect cubes and the sum of perfect cubes. And here they are. And here's the good news. The formula is given on the reference sheet. We have never had that before. With our new next generation Algebra 2 that you're taking, they are giving you the formula. So we always had to teach this acronym to help us with the signs. But I really don't even know if I have to teach that anymore because this formula is given to you. How nice is that? Now, I do have some expert advice. I have done this for a long time, and here's what I think is the easiest. Okay? Use parentheses when substituting in A and B values, and always, always look for that GCF first. That will make your life easy. Okay, so number 1 says identify the A and the B. Oh, so my other suggestion is to identify the A and the B. So I'm going to move this to the next page. We're going to focus on t cubed minus 8. So let me pull up the reference sheet for you, because I don't think we've talked about it yet. This is what your reference sheet for Algebra 2 will look like. Probably nothing that you've seen before. You might have used the quadratic formula before. I'll take that back. And you might have used the arithmetic and geometric sequence before in Algebra 1. That's on the Algebra 1 reference sheet. But here's what you need. Here is your cube factorization rules. Okay, so you're going to have to recognize that it's a cube factorization, but then we're going to use these rules. Okay, so I have t cubed minus 8. So let me go back to the rule. So I'm going to go to the minus one. A cubed minus b cubed. So the question is, who am I cubing to get this value, and who am I cubing to get this value? Essentially, who is my a and who is my b? So if you saw t cubed, who is the a value? Who did you cube to get t cubed? Hopefully you're saying I cubed t. And 8 is my b value. Who did I cube to get 8? Let's look at our, who did I cube to get 8? 8 is a perfect cube because of the number 2. So that tells me b is 2. So the first thing I want to do is identify who the a and the b are. Who am I cubing? Who am I cubing? Now this is simple. I'm going to go to my rule, the minus rule, okay, and I'm going to say t cubed minus 8 equals, okay, t cubed minus 8 equals, the a value minus the b value. So in parentheses, my a value is t minus my b value of 2. Okay, and I'm just going to follow the rule. Then it's going to say take the a value and square it plus the a value times the b value plus the b value squared. Okay, now remember I said always use parentheses when substituting an a and b. So you'll notice I did that. So now I'm just going to keep cleaning this up, and I'm going to have my answer. It's going to stay in a form like this. So I'm going to have t minus 2. If I square t, I get t squared. 2 times t is 2t. And 2 squared is 4. And that is how I factor a difference of perfect cubes. Difference of perfect cubes. Now, you might be feeling like these parentheses don't mean anything, but these can get a lot nastier, and that's why the parentheses are important. And you'll see that as we build here. Let's try another fairly nice one. I'm going to go to what I had as my second one there. Just put it on my back here. P cubed minus 125. And let's just talk through a second one here. Okay. I want to identify the a and the b. Okay, so I know this is a difference because there's a minus sign here. So I want to identify who am I cubing and who am I cubing. So who do I cube to get p cubed? Hopefully you're saying just p. Who do I cube to get 125? Okay, let's pretend I don't know. I'm going to go to that cubed root. I'm going to type in my 125, and I'm going to say, oh, it's 5. Okay, so my b is 5. And now I'm just going to go and fill in this formula. So it's a minus b. That's p minus 5. I'm going to substitute with parentheses the a squared, so that's my p squared, plus my 5 times my p, plus my 5 squared. And then I'm going to clean that up. So I'm going to say that's p minus 5. This is just p squared plus 5p plus 25. Okay. Now I can see if this trinomial can get factored. Let's see. I have to multiply to 25 and add to 5. Well, my only multiples of 25 are 1 and 25. My multiples will also be 5 and 5. Neither of those can add to a 5, so this is factored completely. All right, so you might be saying, well, how does this get more difficult? Well, let me show you an example where maybe it gets more difficult. Number 3. Okay, now remember, step number 1 was to always look for a GCF first. I think I can pull out an 8. So I'm going to get 8m cubed minus 1. Okay. Now, this GCF has to stay in the problem, remember. So the question is, who am I cubing to get this term, and who am I cubing to get this term? Who do I cube? So let's start with the number. Who do I cube to get 8? If I'm not sure, math cube root of 8, 2. Okay, so my a is equal to a 2, and who am I cubing to get m cubed? M. So my a is 2m. My b here, who am I cubing to get 1? Well, that should be a nice easy one. 1. 1 times 1 times 1 is 1. All right, so now I'm going to go to my formula. I want the difference one because this is a minus. All right, now, here's where you have to be careful. You pulled out this 8 already, so I have to keep the 8 out in front of this. A minus b, so that's 2m minus 1, times 2m squared plus 2m times 1 plus 1 squared. Sorry, I'm so sideways here. All right, so I'm going to keep the 8. I'm going to keep the 2m minus 1. Now here's where you got to be careful. You have to square everything in here. And remember, that means you multiply it by itself, or you square each term. 2 becomes a 4, and m becomes m squared. Plus 2m plus 1. Am I factored completely? Can I do a guess and check on this? Oh, let's see. 4, so there's no GCF. 4, I don't think that factors any further. I'm going to go factored completely. All right, let's keep cruising here. 2w to the 9th minus 432. Well, I recognize right away I have a difference. So the question is, are they perfect squares, perfect cubes, or GCF? Well, 2 is not a perfect square. It's not a perfect cube. So those are out the window. So I'm hoping there's a GCF. Now they're both even, so there definitely is a GCF. 432 divided by 2 gets me 216. So I'm going to pull out the 2. I have w to the 9th minus 216. So now again, I'm saying it's a difference. Is it a perfect square or a perfect cube? Let's see, is 216 a perfect square? So I can hit my square root, 216. Nope, not a perfect square. Is it a perfect cube? 216 is a perfect cube. 6 is its value. Okay, so we have to identify the A and identify the B. And again, that just means, who am I cubing to get this? Well, we just said we're cubing 6 to get 216. Who am I cubing to get w to the 9th? So think that through. Who would I cube so I get w to the 9th? Who would I want here? W to what power so I get w to the 9th? So if I'm going power to a power, I'm multiplying, so this has to be w to the 3rd. Now again, once you've identified these, the question isn't too bad, because again, you're just using the formula sheet. Let's fold this in half here so I can see my formula sheet. All right, so I know I want a difference. I really like difference questions, apparently. All right, so I have the 2 we pulled out from the GCF right here. Got to use that 2 first. And now I'm going to go through. I need my A value, w cubed, minus my B value, times my A value squared, plus my A value times my B value, plus my B value squared. Okay, and then I got to clean it up again. So I've got this 2. I have w cubed minus 6. I have power to a power, which is going to get me w to the 6th, plus 6w cubed plus 36. And again, my options for 6 are 6 and 6. Those won't add to a 6. 1 and 36 won't make a 6. 2 and 18 won't make a 6. 9 and 4 won't make a 6. So I think I am factored completely. All right, let's tackle one last one together here. Fold this paper again here. Okay, so again, I have two terms. So it's either perfect cubes, because it could be a sum or a difference, or GCF. So it can't be a difference of perfect squares because this isn't a difference. So is 192, well, I can tell you x squared is not a perfect cube. So I know it's not a perfect cube yet, and I know 192 isn't, but I can verify 192 is not a perfect cube. So there must be a GCF. Okay, so clearly I can take out an x squared. What the heck do 192 and 375 have in common? 192 divided by 2 is 96. 192 divided by 3. 375 divided by 3. I think 3 is my winner. So I'm going to take out a 3 and an x squared. Okay. So if I divide 192 by 3, I get 64, which is good because that's a perfect cube. If I had x to the 8th and I took out x to the 2nd, I'm left with x to the 6th. Plus, this is a 125, and I took out the x squared, so I just have y cubed. Okay, so now I have to recognize that I have a sum, so difference of perfect squares is out the window, but it could be this cube factorization. Okay, so the question is, what makes this cubed, and what makes this cubed? All right, let's start with 64. So again, if you don't know, you can check the cube root of 64. Oh, look, it's 4. So this is 4. Okay, so now I got to talk myself through this. What cubed is going to get me x to the 6th? What number would I want here for power to a power? Hopefully you're going with x squared because I want 2 times 3 to get me 6. Cube root of 125 should be 5. And then y cubed is just y. All right, so now I'm ready to do my factorization. So this time I'm going to go to the sum. Okay, so I'm going to pull out my GCF first, my 3x squared. I've got my a plus b, so that's 4x squared plus 5y. Okay, so now I have to take the a and square it, so that's where those parentheses are important. Minus this time my a times my b plus my b squared. All right, let's be really careful on this cleanup. So I have 3x squared. I have 4x squared plus 5y. Okay, now remember, I'm squaring everything inside here. So I'm either multiplying it by itself or squaring everybody. So I'm going to get 16x to the 4th minus 20x squared y plus, if I square this, 25y squared. And I would say I am factored completely. So the good news is for any quiz, test, etc., you will have this given to you, okay, but you'll have to recognize it as perfect cubes. Also, if you're doing your spirals, etc., this is the very last page of your black math book. Okay, so if you flip to the last page, this is in here. It's also in your notes page. If you look at the table of context, you'll find your perfect cubes here, but it is the last page on the reference sheet in the book. So we're going to tackle the next group in class and just take your time recognizing that they're perfect cubes and who they're cubing.